Okay, so coordinates of A are 1, 1, right? Because to get to point A, you go right 1, up 1.
Yes.
Good. Coordinates of point B, to get to B from the origin, you go left 3, down 1. So it would be -3, -1. You guys get the idea? You remember how to plot points? Okay, good. All right, so when we're graphing an equation, one thing you can always turn to if you don't know how to graph an equation is to just make some points. Create a table of values and pick some points. So this is something you can always turn to, even on the final exam. If there's something that you forget how to draw its graph, just plot some points, right? So if I wanted to graph y equals 4 minus x squared, and I have no idea what that thing is supposed to look like, I just make a table of values. I picked some random x values, integers from -3 to 3, and I'm going to calculate what the y value has to be by plugging into the formula, y minus x squared. So I'm going to have 4 minus, then I have to put in a -3 for the x and square it. So when you square -3, what do you get? 9, 9. Positive 9, because -3 squared means -3 times -3, which is positive 9. So I've got 4 minus 9, which is -5. So my point is going to be -3, -5. And then you guys get the idea. I'll just tell you what these are. We've got -2, 0. And then we've got -1, 3. 0, 4 was done for you. And then we have some symmetric points. We're going to have 1, 3, 2, 0, and 3, -5. Okay, so I only did the workout for the first one. Hopefully you did it at your tables. You can ask me if you have questions. And then you just plot your points. We've got -3, -5, -2, 0, -1, 3, 0, 4, 1, 3, 2, 0, and 3, -5. And then you just connect them with a smooth curve. Anyone know what that thing is called? A parabola. Good. A parabola. Okay. So finding x and y intercepts of a graph. So if we go back to the graph that we just drew, and I want to identify its x and y intercepts. Okay, so what is the y-intercept of this graph? 4. So the y-intercept of a graph is the place where a graph crosses the y-axis. So the coordinates of that point are 0, 4. This is my y-intercept. And then what my x-intercepts, where are they? -2 and 2. So the coordinates of them, if I was going to give the whole coordinate, would be -2, 0, and 2, 0. Those are x-intercepts. So we can identify them from a graph. They are just the places where the graph crosses either axis. That's what an intercept is. But how could I have found them algebraically without plotting the entire graph and looking for the place where it crosses? Substitute 0. You got it. So if I want to find the y-intercept, which variable do I make 0, x or y? X, yeah. Because if you're on the y-axis, your x-coordinate has to be 0, right? So if you're looking for a y-intercept, you make the x 0 to figure out what the y is. So my formula is y is 4 minus x squared. Make x equals 0. Y equals 4 minus 0 squared, and we get y equals 4, which is exactly where we saw it on the graph. There's our y-intercept. And then to find x-intercepts, if you're on the x-axis, anytime you're on the x-axis of a graph, the y-coordinate of that point is 0. Right? So if you're looking for an x-intercept, make y equal to 0 and solve for the x. So I'll have 0 equals 4 minus x squared, And you get x squared equals 4, which means x equals plus or minus 2. The two numbers that when you square them that you get 4. All right, so that was just a little review of things we know about graphing, how to plot points, how to make a table of values, and graph an equation by plotting those points, how to find intercepts. Okay, so the rest of today's class is going to be about graphing utilities, so using technology to help us come up with graphs. So first, I'm going to show you a little bit on a graphing calculator. If you happen to have one, you can follow along. If you don't worry about it because it's not required. So I'm going to do a little demo with a graphing calculator and a little demo with Geogebra. Okay. So you're not required to own one. You don't have to be an expert in how to use these things. Occasionally in class, I'll bring some to class and ask you to do something with it. So, you know, this is just the very basics that you'll need for that kind of thing. So if I want to graph the equation y equals 4 minus x squared, the equation that we just did by plotting points, using my graphing calculator. Here's my smartboard version. So the on button is down here. Turn it on. I'm going to clear whatever's there. Just press clear, upper right-hand side, close to the top. All right, so I'm going to press the y equals button. It's the very upper leftmost button, y equals. And you get a bunch of stuff, bunch of y equals in there. If there's anything in there, we're just going to clear it for now. And I want to enter the equation into y1. So I'm trying to graph y equals 4 minus x squared. So I have the y equals part. I'm going to type 4 minus. My x button is this button right here. That doesn't work. This button right here, it says xt theta n. That is your variable button. Whenever you want to use a variable, that's your button. So x. And then to raise things to a power, you have a special button for squared. For any other power, you use the little caret. Little caret means like raise up to. So I'll use that just because it's more general. X squared. Okay, so we entered into y1, and then we're going to press the graph button, which is the upper right. Why don't I see anything? It's the window. It's not zoomed onto the right part of the coordinate plane, right? The x-axis and y-axis are infinitely long, so that we have an infinite plane, and I have to tell the calculator what part I'm interested in looking at. So we have to choose a window or a viewing rectangle. It's an important consideration. To adjust the window, you press the window button. It's right next to y equals. And you have to give it values for xmin, xmax, ymin, and ymax. You can also give it a value for the scale. That's just the space between tick marks. I typically leave it at 1, but you're welcome to play around with that if you want. So I'm going to just do a standard window, which is -10 to 10 on both axes with a scale of 1. So you can type it in, -10 to 10, scale of 1, then -10 for y min and 10 for y max. And you hit graph again, and this time we see the whole graph. Looks just like the one we drew. Okay, so when I discuss a viewing window, the shorthand that we use to tell someone what viewing window we're using are these, looks like this, right? It's 3 numbers in square brackets. This says -10 to 10, scale of 1, and that's x, by -10 to 10, scale of 1 for y. Okay, so this is just like the shorthand notation of how you would tell somebody what viewing window to use. The scale is how far apart the tick marks are. So like, let's look at this guy. Each tick mark is exactly 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If I change the scale, go to window, let's say I'll change the scale to 5 on the x-axis. that means I'll only have 2 tick marks. It's going to look the same, it's just that it only shows, it counts by 5s now, 5, 10. Does that make sense? Okay. Okay, so a quick way to get the standard window, -10 to 10, -10 to 10, scale of 1, is to use Zoom option 6, Z standard, Zoom standard. And it gives you the standard viewing window. It's just a quick way to get it. All right, so that's the very basics of how to create a graph in your graphing calculator. I'm going to now show you the very basics of how to create a graph using free software called Geogebra. We'll be using this frequently in class for me to demonstrate things, and outside of class you'll be using it to do projects. And if you don't have a graphing calculator, you might use it like while you're doing your homework, something like that. Okay, so if you don't have this yet, you may have used it in a previous course. If you haven't, the website's just geogebra.org, and I believe I gave you directions on how to get it in your first project, which I handed to some people on Friday. I didn't. I will put a handout for how to download it on Moodle. But again, it's a free software. It's super easy to download. Go to geogebra.org, array of download options. Okay, so this is what it looks like when you open it up. The first thing I'm going to do is change my font size because these are like super tiny. It's hard for me to read it. And if you're going to be handing something into me, please do that also, because when you print that, it comes out super tiny and it's hard for me to read. So you go to options, font size. I always change it to 24. Okay, so I'm going to graph the same thing I graphed in my calculator, 4 minus x squared. So the way you graph it is you put your cursor down in this input bar at the bottom, and you just type the equation, y equals 4 minus x. And you also use the caret when you're typing in GeoGebra for an exponent. Caret squared, and you hit enter. It graphs it. And then you can manipulate the window so much easier than in your graphing calculator. You use this little guy that's the move button. And when you hover over all these things, it tells you what they do. But we won't use very many of them. But I'm going to use the move button. And it gives you a little hand. And you can just click. So I'm doing a regular click and holding it down. And you can just drag it around. And then if you want to change the axis scale and dimensions, you move your mouse until it's hovering over the axis and it turns into a little arrow instead of the hand. And then you click and hold, and you can drag down or up to change the scale. And then I can do the same thing on X. Just wait till you get the little arrow, click, and drag. It automatically changes the scale. And then you can add a grid if you want. There's a little arrow here. Click that, and you can choose a grid so that you can see the graph paper. Okay, so that's how you graph it. That's how you change the axes. All right, so you're going to learn lots more about GeoGebra through Project 1. I just gave you like the super basic how you graph something, but there's going to be specific instructions on how to do more fancy stuff in there in Project 1. All right, so if you didn't get Project 1 yet, I'll hand it out in a minute. It's also posted in Moodle. Every project is already posted in Moodle. And for the rest of class, you're going to work on your class activity, which is very short. There's just a few problems to work on, followed by begin work on Project 1. Okay. So if you have a laptop, you can start working on it. Several people could move across the hall to the math studio and use the computers over there. You can also, if you want to do the non-technology piece of it first, you can do that also, and I'll point that out as soon as everybody has a project.